Hello and welcome to my exam video 5. Today we will be talking about point mutations. Here we have a snippet of DNA which contains a sequence that encodes a 4 amino acid protein. It can be more easily seen if I shift the base pairs a bit. Then we'll flip these strands end for end so that the 5' end of our coding strand is on the left. Now I will add the mRNA strand, which is produced by the template strand on the bottom, but whose sequence matches the coding strand on the top. Next, we just refer to the coding dictionary to determine our amino acids. AUG signals the start of translation and codes for methionine. GUC codes for valine, AGC for serine, and AAG for lysine. UAA is a stop codon and signals the end of translation, but does not code for an amino acid. I have removed the template strand as we will not need it. Let us introduce some point mutations so that we can visualize how our protein will change. Where there was previously a guanine, an adenine has taken its place. This is called a transition since a purine has been replaced with a purine. Even though the codon has changed, it still codes for the same amino acid. Therefore, lysine is still the 4th amino acid. This is called a silent mutation since it does not impact the protein. Let's go back to the original sequence. This change was from a thymine to a cytosine. This is another transition since both are pyrimidines. Notably, our second position amino acid has changed from a valine to an alanine. This is a missense mutation since an amino acid has been changed. The change from an adenine to a thymine is a transversion since a purine is being replaced with a pyrimidine. Additionally, the codon has changed. Instead of coding for lysine, it now signals the end of translation, shortening our protein to 3 amino acids. When a mutation upstream results in the premature termination of translation, it is a nonsense mutation. Our last mutation is a transversion since adenine was replaced with cytosine. This time our stop codon has changed and now codes for alanine. This causes the ribosome to continue translation until another stop codon is reached. This sort of mutation is called a read-through.